Witam Państwa
Welcome
ponownie.
back.
Przed nami drugi panel, w którym
This
słyszymy
is
o
going to be the
problematyce,
second
założeniach
panel where we are
i
going
przebiegu
to
konserwacji
listen
archiwalnej.
about the
Zapraszam do mnie
conservation
panią
of
Nelię
the
Jastrzębiowską,
archival
która jest
materials.
zastępcą
And
kierownika
now we are
pracowni
going to
konserwatorskich
listen to the
oraz jej
contribution of Neli
współpracowników, panów
Jastrzębiowska
Szymona
and
Wojaka,
her
Krzysztofa
colleagues, Mr.
Kraśnickiego.
Krzysztof Wojak
Wszyscy
and
Państwo są
Krzysztof
specjalistami z zakresu
Kraśnicki. They are
konserwacji
all
papieru.
specialists in the
Witam
conservation of
Państwa i
paper.
oddaję głos.
So, ladies and gentlemen, welcome and over to you.
Witamy serdecznie w części prezentacji dotyczącej badań
Welcome
laboratoryjnych.
at the presentation concerning
laboratory
laboratory research. We would like to discuss the physical and microbiological analysis and of the archival materials. The conservation process begins with detailed laboratory research, which helps to identify degradation issues and develop strategies to prevent further damage, which are microbiological factors, biological factors such as insects, and physico-chemical factors. The greatest threat is the filamentous fungi, which are known as mold. The spores are present in the air, but they pose no threat unless there are favorable conditions, that is, elevated humidity above 65% and poor air circulation. Microorganisms, through their enzymatic activity, weaken the structure of paper and cause stains, leading to complete destruction of the object. Also, they can be risky to humans by means of mycotoxic productions, which can be allergenic and even carcinogenic. That is why we need to see whether new objects are not infested by microbes. If they are, they need to be separated from others to prevent spore from spreading, and disinfection is carried out by conservators. The identification of molds is made through macroscopic, microscopic observations and also by culture, which helps to classify the mold species. The most common fungi are Aspergillus, Penicillium, Cladosporium, and Hetopium, which can lead to significant paper damage. The most frequent are Bacillus fungi, and because they pose a significant risk to objects, we have disinfection, mechanical removal, and environmental control to prevent further degradation. Apart from traditional microbiological methods, we have molecular methods such as real-time PCR, which help to identify the species of DNA, which is crucial for diagnosing the biological threats. Currently, such solutions are implemented in microbiological and genetic research, which allows to identify microflora, which helps us to disinfect them effectively with minimal impact on the surface. The insect damage caused by the insects is irreversible because the documents can be eaten by insects, mostly silverfish, which consume organic substances such as paper, adhesive, leathers, and canvas. They like poorly ventilated areas, causing to surface damage and also significant gaps. Wooden furniture can be attacked by beetles, which is called woodworm. Their damage is small round holes with some powder which is oozing from inside. As they feed on furniture, we need to monitor the objects in the archives. The damage caused by insects can be prevented by cleanliness and frequent inspections. We can also use sticky tapes, which will help us to detect the problem and to intervene. Disinfecting paper is a key process in protecting historical materials from microbiological degradations. The methods help to remove the mold. This is fast and safe, but they don't eliminate. Chemical chemical disinfection with ethylene oxide or ethanol might destroy the pathogens but also damage the objects. That is why we decide for ozonation, UVC radiation, but also require precise control to avoid harm. Freezing is safe and effective, but we need to be very careful at controlling to avoid the condensation of steam. We need to choose the method depending on the type of contamination. Each of the methods has its advantages and downsides, and their application must be carefully planned and adapted to the object. In the physical and chemical laboratory, we have a number of studies. The first of them is Fourier transferred infrared spectroscopy, that is FTIR, which is a non-destructive method that allows for the analysis of the chemical composition of paper, of the surfaces and applied layers, which is crucial for identifying degradation and conservation for objects. XRF, that is X-ray fluorescence spectroscopy, is also a non-destructive method which allows to analyze the elemental composition of an object. In the case of archival materials, it helps to determine the elemental content of the media and contaminants. Optical and digital microscope helps to have a close examination of the structure and also identify fibers that make up the paper. FTIR and XRF are the primary methods used for studying and examining paper materials because they are non-destructive, and also we have the prevalence of organic materials and the protective coatings and also writing media. Both spectroscopies help to identify the elements and carriers present in the media used to decorate or color the paper. This helps to determine the materials used by the people who created documents or illustrations, which is important for understanding the artistic techniques. These techniques are useful for the analysis of chemical composition, which is connected with the presence of elements such as iron that accelerates the depolymerization of paper. In case of the glues and adhesives, we analyze the infrared of the materials such as polyvinyl alcohol, polyvinyl acetate, wax, or rubber. Also, this helps us to identify which gluten proteins are used based on the unique absorption patterns of the infrared spectra. Using the physicochemical methods, we are able to verify the authenticity of documents because we see which techniques were used in their creation and which devices were used to produce. So, for example, the printing techniques and covering agents. For the methods use of the authenticity research, we can include, for example, the identification of stamps and the imprints, revealing legible and illegible written parts, the examination of the damaged documents, that is burnt, moldy and torn, the detection of additions, overprinting or removal, revealing the intended writing, or to find which agents were used to cover the documents, and also the analysis of the paper condition, which helps us to identify their age and to see whether it was prepared or fake.
Identification of fibers using microscopic examination provides quick and accurate results and is easy to apply for identifying plant fibers such as hemp, jute and flax, which are additives to pulp and wood pulp, the main components of paper. The advantage of this method is that the test can be performed even if the available sample is small, and for example, cotton in longitudinal view resembles a spiral unnecessarily twisted tube with a rough surface. The microscopic size fibers should be mechanically separated and placed in the most loosely arranged form. A concentrated sodium hydroxide solution or a solution of concentrated hydrochloric acid destroys animal fibers such as silk. Dilute acids dissolve plant fibers, and a 2% sulfuric acid solution can be used to distinguish them. Specific reagents such as Schweizer's and Herzberg's reagents are used to determine the characteristic reactions of certain types of fibers. By selecting appropriate solvents or reagents, fibers can be easily distinguished from one another. Knowledge of the quality of paper components can help determine how quickly the paper will degrade. Another issue currently being analyzed in our physicochemical laboratory is the identification of copying pencils. This involves a comparative analysis of the organic composition of traces left by the writing tool in the form of clay impregnated with dye on the surface of the documents. Identification is carried out using the FTIR method by applying various pencils to the paper surface.
We can use different pencils. The comparative material are similar copying pencils of similar morphology. The measurements were entered into a database which allowed reuse of spectral data during the identification of future samples. An additional criterion of selection is organically dissolving the writing tool, which allows defining what solvent was used in the given material. The results allow quick and non-destructive analysis. It's important because they cannot undergo regular conservation processes like those that use lead and are difficult to tell apart. Our laboratory also uses aging in this method. The samples of methods undergo extreme environmental conditions, increased temperature, higher levels of ozone or UV levels. Normally, we speed up the aging that would normally take years. This gives us information about the potential speed of degradation of our material and efficiency of various methods of conservation, like deacidification, lamination, and use of new means. Changes of temperature and humidity speed up the degradation of paper. This allows the speed defining the speed of degradation. pH testing by contact method that allows defining the pH is very important for historical paper. The material, for example, the wood pulp and some glues often make this paper acidic, which in longer perspective hydrolyzes celluloses, and that means absolute degradation. What makes paper change color from white to yellow and also makes it breakable. A classical method of testing was making cold and hot extracts. However, that's a destructive method, which means it had to be replaced with a contact technique. So now there are only several drops of deionized water and an electrode is used for the actual measurement. With too low pH, those items are deacidified in our conservation. Laboratory can also find the most effective means of conservation, for example, solvent to remove the unoriginal layers of protection. First, the original material and the coating are studied. The coating has to be removed after modeling. Tests of solubility are conducted. Two main factors must be considered here. The first is solubility of a given substance in different solvents to achieve the highest efficiency, which will have those objects more shortly exposed to solvents and increase also the safety and security of conservation staff. The second reason is the potential solubility of colorings and the media. So we must choose the solvent that will efficiently remove that layer and have the smallest possible impact. Thank you very much for your attention.
Dzień dobry.
Good evening.
Pracownie konserwatorskie
The conservation studios opened in June 2003. They employ experts in paper and leather conservation, easel painting and wall painting, also conservation of metal, elements of architecture, but also chemists, microbiologists, and experts in photographic documentation and digitization. We, generally speaking, work with preservation of the original historical substance. That's the assessment of the condition, valuation, and also us embarking on conservation. Among the objects that are in the care of conservation experts are archives that we're discussing today. That is, the documents that are mostly paper-based. Paper, as material for writing, has a long history. Simplifying, we can say that it was invented early in the 2nd century AD in China. Over several centuries, the art of papermaking spread from China to the neighboring countries until in the 12th century that skill reached Europe. The early paper was handmade from linen and hemp rags. It was high-quality material, even if made from waste with long cellulose fibers. So that gave the paper excellent strength. That is why old books we can see in museums, codices, manuscripts, and early printed works remain in excellent condition. The invention that revolutionized industrial papermaking was the paper machine developed in France at the end of the 18th century. The discovery made it possible to mass-produce paper. That required available raw material, wood. Now, wood fibers are much shorter and produce a weaker material. Now, the method of attaining these fibers and new sizing agents resulted in rapid degradation of paper produced from the 19th century onwards. Paper yellows, becomes brittle, sometimes disintegrates into dust. The documents from Auschwitz were created on machine-made paper, and we can observe all its weaknesses in the condition of these archival matters. The documents we deal with were created on machine-made papers whose quality greatly varies. A great example here is a set of documents related to SS Hygiene Institute. The documentation, consisting of orders and results of studies concerning infectious diseases and experimental studies, was conducted on papers that varied significantly. Most of those were special forms for laboratory use, but often also random paper types were used. They were not made for office purposes and were not conditioned for long-term storage. The whole collection, in the whole collection, we identified 175 different types of paper. Composition of fiber, when analyzed, showed that most of that paper was made from coniferous wood pulp, less often from deciduous trees, with various proportions of groundwood pulp. There were also papers that were 100% groundwood pulp. That's the cheapest and weakest material used in paper production. Sometimes this paper can tell us something about the location of its production. Watermarks visible against the light on several sheets help us date and locate production sites. For example, paper bearing a watermark of Mercury on the globe was produced in 1936. The paper with watermark reading Hard Post, dated 1942, was made in that year in Austria, in Penning. Another watermark with a winged circle was made the wheel. The one which reads Invictus in the watermark was produced in a German paper mill. The archival materials include also 2 documents written on tissue-like paper, resembling toilet paper or crepe. Some documents were written on paper from books. One such document still bears the round seal of a library in Marburg. Writing media used in these archival matters also vary. In the SS Hygiene Institute collection, we identified now 131 different writing media, lead pencils, copy pencils, color crayons, various inks, typewriter, print, and also carbon copies. And this diversity of materials presents a significant challenge in conservation. In 2011, we conducted a comprehensive assessment of the state of presentation of all archival matter held in the museum. We assessed the acidity and yellowing of the paper, the condition of the writing media, presence of dirt, stains, tears, losses, and also signs of microbial activity. These studies provided us with very valuable knowledge about the overall condition of the collection, percentage of objects in good condition, needing new housing, or conservation intervention. That let us create a 30-year action plan prioritizing the archival materials in need of conservation. And that work is now ongoing. The documents related to Auschwitz have often had a long journey, and their history is inscribed on them. These can be folding marks. Often in these places, paper is heavily worn and it easily tears. History also left different stains, also rust from metal elements, and many more. There are also traces of prolonged exposure to moisture that cause bleeding of the media, and also signs of microbial growth in the form of characteristic spots, softening of the paper, and even its loss. That damage is treated by conservators as part of the original objects, imprints of history on the material itself. The first stage of conservation of paper documents is to lose their surface from loose dirt. This process is done carefully to avoid losing any traces of history. It's very important because even though the principle of reversibility is a core principle in conservation, cleaning is a process that cannot be reverted. Paper is cleaned with various erasers, sponges, to remove only the surface dirt that could interfere with the following treatments. The main enemy of paper is acidity, which causes yellowing and rapid shortening of cellulose fibers. This results in tears and losses. Sometimes we find documents, archive documents, that break on touch. The case were notebooks of a former inmate of Mauthausen and Auschwitz. The poor quality of paper and probably its past made those pages extremely fragile. And this paper, acidic paper, must be deacidified in conservation. As of today, there is no method that would allow deacidification, total deacidification. Unfortunately, only a temporary method is to provide a solvent that will eliminate reactivity of the acid that does not destroy cellulosis and slows down the process of degradation. However, you can't do any mechanical or automatic things. One of the key principles is to treat each object individually, even if these are similar objects that are present in large numbers. An excellent example of this approach here, when we approach deacidification, are Central Bauleitung diazato prints, copies made on paper, using exposure. The dyes that sensitize the paper are sensitive to strong bases, which means deacidification would have it blackened and information would have been lost. Currently, the problem with deacidification of such archives is researched in our lab, and we'd like to find a way of slowing the process of its natural destruction without the danger of destroying such a copy. We were gradually developing our ways of conservation. The evolution of working on the gaps is a good example. In the beginning, according to the binding principles, we often provided some materials to bring them up. With time, we found that the fewer the noticeable elements you leave, the better. If safety and security of an object does not call for any complementation, we only work on the places that are broken. You put the Japanese paper, very thin, transparent camp letters and the pages from the notebook after completed conservation work. Letters cause other problem. Camp letters are given to the face by the families of the former prisoners. They were often used by strange ways of holding them together. Various adhesives, paper tape, scotch tape, edge strips from stem booklets even, and in some medical plasters. There are examples where one single letter has several types of different adhesive tapes. We must remember that these letters for the family were the only memento of the murdered members.
Their frequent folding and unfolding led to numerous tears. So they were easy to use, and in a longer use, it led to the degradation, leading to discoloration and also some damage caused by deteriorating adhesives. Because of the highly degrading nature of the adhesive tapes, it's being removed during conservation. First, the plastic film is peeled away, and then the adhesive is carefully extracted from the paper using organic solvents. This is a long process that requires precision and patience. Another conservation step is pressing the documents, particularly when water-based adhesives are used to repair tears. Moistening of the paper before pressing is also important to activate the deacidification process. However, there are some archives which are not pressed, for example, the plans for central ball items, which were used during the expansion of the camp, which were folded. On the other hand, these elements make the digitalization difficult or even impossible. So in such a case, we decided to find a compromise. So the plans were gently unfolded and then flattened with light weights, and the entire process was repeated a number of times until satisfactory results were achieved. Also, a minimalistic approach was used for the conservation of the covered notes. The folds and tears tell an important part of their story. That is why they could not be lost during conservation. And after a detailed analysis of the damages, torn and crumpled pieces of paper posed no risk, and that is why they were left in the original condition. Only the loose fragments on the edges were kept, because there was a risk of detaching. After the conservation, documents are scanned so that the researchers and other people who are interested in the content, they could have the access to digital versions, and then the documents are returned to the archives and they are stored under the safe conditions. Thank you very much for your attention. Thank you very much for the presentation. These presentations brought a number of interesting information about the conservation of paper materials. The works that we listened about are possible thanks to state-of-the-art workshops and laboratories which are in the museum, and also thanks to the very qualified, highly qualified staff. Ladies and gentlemen, this is the end of today's session. It is the second out of the 3 planned, where we would like to show the entire range of activities. And the next session will be devoted to the collections and conservation of objects. Ladies and gentlemen, I would like to thank the speakers and everybody who was present online. See you during the next session.